Yesterday we finished the first half of that section 1.2, and today we will do the second half on radicals. So 1.2 part B on radicals. Or square or root. Now you may wonder why radicals is associated with the word root, but the word radical comes from the Latin word radix, which means root. Okay, so that's what the radical means. That's the root. So when we say radicals, refer to people, radical people, it may refer to grassroots people at the more common people. Okay, but I don't know. I don't know about the social meaning of the word radical. What I was told, like around 1970s, when somebody say we are radical, it means we are cool. You know, when they say, Thomas, you are so cool, they say, oh, Thomas, you are so radical, like that. But that was 1970s, I was told. I was not born yet at the time. Well, anyway, what is nth root? Nth root of x refers to is the number let's call this nth root of x equals to y is the number y such that y to the n equals to x. Now this n here is also called the index. And this x here is called radicand. Okay, now the thing is, if there's a rule, if y may be positive or negative, then we take the positive branch. For example, when we say square root of 9, now notice that 3 squared is 9, negative 3 being squared also 9. So there are actually two numbers which when we square we get 9, right? Now if there are two possibilities, we will choose the positive branch. Okay, now in our textbook we call it the principal branch. Okay, we call that the principal branch. So the square root of 9 is 3, not negative 3. If we want to have negative 3, then we will get negative square root of 9. Then that will be negative 3. But the negative 3 there because we get the negative first and then the 3. Okay, so negative 3, like that. Now, of course, if there's only one option, then that will be the option, the only option you have. Let's say, if we say cube root of 64. Now, what number being cubed equals to 64? Now, if we only look at real numbers, there's only one option, that is 4 to the power of 3 gives you 64. So this is 4. Okay, and cube root of negative 64 equals to negative 4. Now, square root of negative 25, for example, is not a real number. because any real numbers, if you take the square, it will always be 0 or positive, cannot be negative, right? Any real x, when you square it, it will be at least 0. Okay, so that's what it means to be the principal branch described in our textbook. If it has more than one real numbers to give you the radicals, the value of the radicals, we will choose the principal branch, which is also called, which is a positive branch in our case. Okay, that's for the radicals. Now I will go ahead to examples. So continue from what we did yesterday. The suggested homework was number one, I think from number 11 to number 31. Those are for integer exponents. Now, what happens if we have rational exponents? Let's say, for example, we do number 34. 34, am I recording this? Yeah, number 34 from 1.2. If you have your textbook, please take a look. Okay, number 34, we get negative 6 x to the 7/5 times 2 x 8 to the 5th. I think this one is easy. When we multiply the coefficient by coefficient, this gives us what? Negative 12, right? And then when we look at the x to the 7/5 times x to the 8/5 will give us x to the 7/5 plus 8/5 is 15/5, which is 3. So this is x cubed. That one is easy. Okay, number 38. Number 38, 25 c to the power of 4 to the power of 3/2. I'm sorry, to the power of negative 3/2. I missed the negative sign. This is equal to 1 over 25 to the power 25c to the 4 to the power of 3/2. You see how I get rid of the negative exponent? Right? To make it positive exponent, I bring it down or I bring it up. Numerator becomes denominator or denominator becomes numerator. Okay, now and then another thing is that the thing that I forgot to mention earlier is this. When we have the nth root of x, this means nth root of x, this means x to the power of 1 over n. Okay, so the over 2 here means square root. Okay, over 2 there means square root. Let me write it first. We can see this as 1 over the cube of the square root of 25c to the 4. Okay, so the square root here, of course, because it's square root, we don't write the 2 in the pocket, right? We don't write the index. That becomes 1 over 5c squared to the power of 3, which is 1 over 5 cubed is 1.5, z squared cubed is c to the 6. How about number 42? Number 42, we have negative y to the power of 3/2 over y to the power of negative 1/3 in quantity to the power of 3. I think what I will do, I will simplify the guy inside the grouping symbol first. Okay, I will simplify that first. And you see that the one at the bottom have negative exponent, right? To make it positive, I will bring it up. So this is equal to negative y to the power of 3/2 times y to the power of 1/3 to the power of 3. And let's add the guy inside the house. So this will be negative y to some power to the power of 3, right? Now this sum power here will be the sum of these two numbers. Okay, let me do it aside. 3/2 plus 1/3 LCD 6. That's 11 over 6. This is 11 over 6. And then I use power rule. I'm sorry, I should say 11 over 6, not over 2. And then this will be negative to the power of 3 is negative. Right? Negative to the power of 3 is negative. Let's say this. Negative to the power of 3 is negative. And then y to the 11 over 3 to the power of 11 over 6 to the power of 3 is y to the 11 over 2. Okay. Now let's go on. Let's go on. How about number 48? The question is rewrite using rational exponent. So basically we rewrite the radicals as a fractional or rational exponent. Let's say number 48. Number 48. Cube root of x cubed plus y squared. This is equal to x cubed plus y squared to the power of 1/3. Oh, by the way, some warning. Some notes. It is true that if I have x squared, y squared to the power of 3, for example, this is equals to x to the 6 times y to the 6. That's true. Now, however, x squared plus y squared being cubed is not equals to x to the 6 plus y to the 6. It's not. Well, we're supposed to FOIL it, right? Okay, the expression here, for example, the expression here, it looks like, the expression there looks like x squared y squared times x squared y squared times x squared y squared. That's how we get that x to the 6, y to the 6. Okay. However, the expression here is not. This is x squared plus y squared times x squared plus y squared times x squared plus y squared. So we need to do the FOIL twice, right? We need to FOIL this first, this guy here. You need to FOIL this first, and whatever the outcome, whatever the product, you need to FOIL that further. You see what I mean? Okay, so no, the result is not the same. You know that when you FOIL 2 terms by 2 terms, you should get at least 3 terms, right? Okay, so please distinguish those two. In other words, I cannot simplify this any further. That's the furthest I can go. Number 52, cube root of r cubed minus s cubed. This will be r cubed minus s cubed to the power of 1/3. Another note, as much as possible, do not write fraction using that slash notation. Let's say something over this like that. No, avoid that. Instead, use this notation, the horizontal line one. Okay. By the way, you know that division sign, the division sign look like that because of something over something. Okay, so we use horizontal line instead for our division sign, and the fractional notation actually looks like that, not like this. Okay, now under what situation then, Thomas, you don't mind us using this notation when it is exponent? Sometimes you have multiple exponent, then it's better for you to use this. Let's say the one I did here. See, I have this exponent, the exponent to some exponent, right? So because I have nested exponent, then you may use that. Okay, but if you just have a single exponent like this, yeah, avoid using that slash here. Okay, I don't mark you wrong for that though, but I have seen students get confused because their own notation, and it sounds silly because it's your own notation, but you get confused yourself. Okay, so please avoid using that fraction, that slash notation. Okay, we go on. Let's say we do number 56. So far, it's just routine, just rewriting things. Number 56, part A, rewrite using radical notation. Sixty-four y to the 1/3. Now notice that this exponent here only applies to y, not to 64. Not to 64. So when you write that in radical notation, the 64 should not be under the influence of the exponent, therefore not under the radical. Now the exponent only applies to y, the 1/3 only applies to y, so the index 3 only applies to y. Okay, now contrast that with part E, where we have parentheses 64 y to the 1/3. Okay, now this is equal to cube root of 64y, which of course cube root of 64 is 4. Cube root of y. Okay, this example actually very similar to this question. What is -3 squared? -3 squared is -9, not +9, not +9. If you are squaring -3, then this is +9. Okay, so the idea of what we did a long time ago in pre-algebra now being carried over into this radical notation thing. Okay, now anything from here, just practice in simplifying. Let me pick, for example, number 64. Simplify. Number 64, simplify square root of 16 a to the 8, b to the negative 2. Now, square root of 16 is 4. Square root of a to the 8 is a to the 4. And square root of b to the negative 2 is b to the negative 1. But we don't like negative exponent. So I will rewrite that as 4a to the 4th over b. Okay, number 68. How about the square root of 1 over 3 x cubed 1? Now, the square root of quotient is equals to quotient of square root. Which becomes, which becomes 1 on the top, and at the bottom you see that you have x squared here. Maybe let me rewrite it first so that you can see better. So I will rewrite it as 3x squared times xy. Right, now the reason I rewrite it first so that you see that x squared, when it comes out from square root, it becomes just x outside. Right, so I have x here, square root of 3xy. Now, here's another issue. Besides that we don't like negative on the denominator, we also don't like to have radical on the denominator. So how to clean it up? How to make it better? We multiply the top and the bottom by square root of 3xy. But simplify that first. That's one thing you can do. Okay. Now, the reason I multiply by itself is because I try to use this property here. The square root of x, when I square it, it will cancel the square root. Okay, but of course we need to assume the x to be non-negative. Okay, to be more precise, in this case the x has to be positive for that to happen. Okay, so the square root of blah multiplied by square root of blah equals to blah. Okay, as long as the blah is non-negative. Now, therefore, I will get square root of 3xy over x times, now the guy in red here will become 3xy, which is square root of 3xy over 3x squared y. Now this is the standard procedure. What I show you here is standard procedure. Alternative way to do this, if you happen to see already since the very beginning, you know what, the guy on the denominator is not does not give me a nice thing. Okay, so what you will do is under that square root, you complete the square. So this 3 here, I need another 3 to make it square. Right, so on the top I multiply by 3 also. So the x cubed, I need another x. I need another x to make it perfect squared. So it becomes x to the 4th, right? And for the y, I need another y to make it y squared. So you basically build it up, okay? And this will become square root of 3xy over 9x to the 4th y squared. Then this is square root of 3xy on the top, big over 3x squared y at the bottom. That's another way to do the work. Alternative way to do number 68. number 72. Let me do it here. Number 72, I have fourth root of x to the 7th, y to the 12th over 125x. Let me simplify that first. I can cancel one of the x. So I get x to the 6, y to the 12 over 125. Now notice that this 125 is actually 5 cubed, right? Let me change it right away here. This is actually 5 cubed. Now I need to have the power of 4 so that I don't have radical. I don't have a radical at the denominator, right? So let me multiply by another 5 to make it 5 to the 4th at the bottom, right? So I now have 4th root of 5 x to the 6th, y to the 12th over 5 to the 4th. Now that way, then I get the 4th root of 5 x to the 4th x squared and y to the 12th. It's already to the power of the power of 4, right? Okay, so I don't break it up further. And at the bottom, I have just the 4th root of 5 to the 4. This will then becomes the 4th root of 5. So this guy stays inside, right? Okay, now then for this guy here, I have x to the 4th and the 4th root comes out. And I have x squared left in there. So the blue part becomes this. Okay, oops, I don't have enough space, huh? Sorry. So x to the 4th comes out, becomes x because that's 4th root of x to the 4th. Y to the 12th under 4th root becomes y cubed. So I get 5x squared there. This is the 5. This is the x part. This is the x. Now at the bottom I have only 5. So basically you deal with them one by one, with the coefficients, with the x, and then with the y separately. Okay, that's for number 72. How about number, let me jump ahead to number 78. Number 78, I have square root of 5xy to the 7th. Is it to the 7th? Yeah. Times square root of 15 x cubed y cubed. X cubed y cubed. Of course, there are many ways to do this problem. At least 3 different ways. But if you ask me to do this problem, I will do it this way first. I will put them together under one square root. Okay, so I will get 5 times 15 x to the 4th, y to the 10th. Right? Now, this guy here is a perfect square. We have square root, right? This one also fine. So later on, they will come out nicely. Our issue is with this 5 times 15. Now notice that I can rewrite that as square root of 5 times 5 times 3, x to the 4th, y to the 10th. So the 5 times 5 under square root becomes 5, x to the 4 under square root becomes x squared, y to the 10 under square root is y to the 5th. Square root of 3. Okay, so this part here now becomes this. This becomes this. This becomes this. Right? But once you becomes x squared and y to the fifth, it's no square root anymore. The one still inside the square root is just this guy here. Okay, just that one guy. Now that's for this section about radicals and rational exponent. Suggested homework from here. Continue. Suggested homework from 1.2b is number 33 to number 79. Just do the odd ones. Okay, just do the odd ones. And I hope you have the book as soon as possible. Like what I said yesterday, get the book. If you don't have the book, then get the electronic copy, the ebook. Okay, get the ebook. I need you to be able to get the book, textbook as soon as possible. And if you then want to have the hard copy of the book, then you buy it separately. But at least for now, you get the ebook first. Okay, you get the ebook first. I'm not sure if I have the PDF file for this 1.3. I usually try to get it. But to be honest with you, if I have it, it must be an illegal copy. So I should not share with you anyway. Okay, I'm sorry for that one. I'm sorry for that one. I wish I can do it, but no. Okay, I go on to 1.3. Let's go to 1.3. This 1.3 here is actually more crucial. This 1.3 here is actually more crucial because in this section, we will learn the first one called that part A, simplifying polynomial. Basically, when we add, subtract, multiply, I don't think we do dividing yet. Some simple division and simple division. And then the second part is actually the hard one. The second part is factoring. Now the thing is, I will just do a very brief review on factoring. And then from there we go on to rational expression. So when we add or subtract rational expressions, and maybe I start with multiply and divide first. Multiply, divide. Then the hard one is add, then subtract rational expression. Now, mind you that every time you have the word rational, have in mind that it is referring to fraction. So rational expression refers to something like some polynomial divided by some polynomial. Okay, that's rational expression. We'll see more details later on. Okay, let's do easy stuff first. Let's do easy stuff first. Part A, simplifying. Like number 2 in our textbook. Number 2 in our textbook, we have 3u minus 1 times u plus 2 plus 7u times u plus 1. Now, the one here we will distribute. That one is easy, I believe. Right? But the one here we will FOIL. Right? Okay, now when we FOIL that, if you can do it faster, that would be great. If not, then you will write more. But the way I see it is the following. 3u times u is what? 3u squared, right? Okay, now the thing is, you will see that the middle, the outer and the inner will combine. Right? The outer is 6u and the inner is -u. Right? So when they combine, it will be, you know what? I use red color here because I used red earlier, 3u squared. And then I use blue right now, plus 5u. And finally, the last will give you -2. Okay, my key point here is as if it is possible, try to skip that middle step of FOIL. Basically, combine the O and the I, the outer and inner, right away, if possible. Okay, if possible. That's how I get this 5u. Okay, now then I go on the distribution there. This is plus 7u squared plus 7u. Put them together, give us 10u squared plus 12u minus 2. Now, what happens if we have that simple division? Basically, if we divide by only one term, number 4, 6x squared yz cubed minus xy squared z all over xyz. Now, if we divide only by one term, then the first step we will do is to split them. So I rewrite the first term on the top over the denominator minus the second term on the numerator over the denominator, the single term there. So you see, if it is only one term at the bottom, I split them. And then from there, I simplify one by one. I get 6xz squared minus y. Now, later on, we will learn what happens if we divide by two terms. Okay. Now, number 6. We see 5x plus 3y, 5x minus 3y. Now, of course, you can just FOIL this. Right? You can just FOIL this. However, in this case, you see we have some pattern. We have 5x plus 3y times 5x minus 3y. So notice that we have two same terms with opposite operation in between. Now, if we have that situation, then we do what we call difference of squares product. Difference of squares. So please remember this, which then equals to 5x being squared minus 3y being squared, which will be 25x squared minus 9y squared. Okay, now don't worry, you can FOIL this if you want, even though I think if you are, once you are at this level, you should be able to see this as difference of square. In fact, if possible, skip this part here. Just go to the final answer right away, if possible. Okay, this question is too simple for you to, I mean, your brain can work faster than you write in this case. Okay, now of course, once it gets more complicated, then I expect you to write more, but this is a simple one. for pre-calculus class, I do expect you to be able to do it visually and write the final answer directly. Okay, number 8, on the other hand, is slightly different. Number 8, we have 5x minus 4y squared. This is the perfect square case. As I have mentioned yesterday, for perfect square case, you need to remember the pattern. You can foil that. Again, don't get me wrong. You can foil that, but if you do long way for every problem, eventually you don't have enough time during your test. I know you may be the one complaining, Thomas, not enough time. Your test is too long. Nah, you memorize too little to skip steps on obvious questions. Okay, so I want you to memorize this. This is a squared plus minus 2ab plus b squared. Now, I hope you remember this. Okay, so even though we are dealing with simple problems, in between, I kind of remind you which are things you have to memorize. Okay, you can only memorize this if you do enough problems. That's the thing. You can only memorize this if you do enough problems like that. So you may need to go back to your intermediate algebra or even your algebra 1 to do more exercise from those sections. Okay. So in this case, this will be, let me slow down a little bit, but I will rewrite it as 5x in square minus 2 times first term times second terms plus the second terms squared, which will be 25x squared minus 40xy plus 16y squared. Once we see that part, then we can go on to, for example, number 10. It gets a bit more complicated. Number 10, we have square root of x plus square root of y squared, square root of x minus square root of y squared. Do we do the FOIL first, Thomas? Yeah, you can. But if I were you, I will see it this way. You know what? I factor this square out. So I make it looks like this. Maybe I use that color so that you can see better. I factor the square out. Okay, and then inside I have square root of x plus square root of y times square root of x minus square root of y. Now I hope you understand why I do it this way. The reason is I basically massage that in a way such that I can just deal with this first. Now notice that it actually follows the difference of squares pattern, right? Blah, sorry. This blah plus blah, blah minus blah. Do you see that? Right? I try to catch that, the difference of squares. But of course, for you to be able to approach this way, you need to see that pattern first and realize, you know what, I can do it another way instead of just standard FOIL and standard FOIL that we did here, right? Instead of doing the standard way, let me manipulate it the following way first. Okay, now then from here you see, oh, you know what, this red part here becomes x minus y squared. Now once we get here, it gets a lot easier. That will be x squared minus 2xy plus y squared. last part from this first part here, the last topic from this simplifying part here is what happens if we have the power of 3? Oops. What happens if you have the power of 3? If I have x plus 3y to the power of 3 as in number 12. Now, the way we approach this will be, I will make it into squared first, x plus 3y times x plus 3y squared. Now, the reason is because I know how to expand this using the formula I have above. Right? So this will be x plus 3y times x squared plus 2 times x times 3y plus 3y squared. That's 9y squared. Go a bit further, this is x plus 3y times x squared plus 6xy plus 9y squared. But we are not done yet. We are not done yet. What we need to do next is to FOIL this further. We are done with only the square. We need to FOIL this further. So basically you need to distribute the x and then distribute the 3y. And then combine like terms after that. Okay, now I will give myself a little break. And this question, actually, I want you to continue on this. Okay, this should take you like around 2 minutes, maybe. And then let's take like around 10 minutes break. We come back at 12:10. Okay, now that's for multiplying, dividing, adding, and subtracting. The second part is the one a bit longer, but our textbook actually gave only a few problems there because they assume you will do factoring again when we do rational expression. So let's see a brief outlook on factorization. Now, I categorize 5 different types of factorizations. The first one is greatest common factor. In fact, for any type of factorization, you always need to check for this one. Always need to check for this one first. Always check for GCF first in every factoring problem. Okay, in every factoring problem. Now, and then the second level, the second type, I prefer to call that the second level, is grouping method, factorization by grouping. And we know that we may do grouping if usually the polynomial has 4 terms. It can be 6 terms also, or 8 terms, or 9 terms. Basically, it's not a prime number of terms. Okay, so if it has only 3 terms, then you cannot do it by grouping. If it has only 5 terms, then you cannot do it by grouping. Okay, unless you manipulate that another way. Okay, now let's say if we do one example. Let's say, for example, we do number 26. in our textbook, number 26 on 1.3. I have 5x cubed plus 10x squared minus 20x minus 40. Now, always check for common factor first. Here I have common factor 5. So I factor 5 out, I get x cubed plus 2x squared minus 4x minus 8. Then from here you see, oh, you know what? I have 4 terms inside. This is the first 2 terms. This is the last 2 terms. So I basically group them into 2 halves right now. And in the first 2 terms, the common factor is x squared. And in the last 2 terms, the common factor is negative 4. Okay, notice that I always follow the sign I have here. Okay, I always follow the sign I have there. And then you notice that in that group, I grouped them into 2 halves, right? In that group, we have common factor again. We have common factor again. And that common factor is a group. Okay, instead of one single expression, it's actually a group of x plus 2. So that's why there are actually 2 reasons we call this grouping method. There are 2 reasons we call that a grouping method. First, because we group them into, in this case, 2 halves. But another reason is because the common factor is another group. Okay, if you think about this, among all 5 factorization methods, this is the only factorization that requires 2 steps to do. So when I do factorization by grouping, you will see it takes me 2 steps instead of only 1 direct step. Okay, so let me continue, and I will get, this is 5 times x plus 2, that's the common factor, I take it out, and then x squared minus 4. Okay, so this x squared minus 4. X plus 2, I factor it out, right? Okay, now, and you see that this happens to be another special factoring. That's difference of squares, which if I can go further, I need to go further. 5 x plus 2, x plus 2, x minus 2. I think this is simple enough for you to see. Okay, then we go on. This is 5x plus 2 squared x minus 2. Okay, so the principle of factorization, as long as you can factor further, you have to factor further. Okay. Now, the third type is polynomial. I'm sorry, not polynomial, trinomial. To be more precise, it's trinomial with leading coefficient 1. Trinomial with leading coefficient equals to 1. Now, our textbook doesn't have example on this. Let me make my own example. Suppose, for example, we need to factor x squared minus 5x minus 14. Because it's trinomial, if it is factorable, then it must be 2 parentheses. 2 parentheses must be x and x here. Okay, and if the sign is negative, then the sign, the last sign is negative, then these two numbers must be opposite sign. So let me put plus minus right away. That's the only way to get negative number as a constant. Okay, now then think about what number times what number give you 14, but the difference is negative 5. So what times what is 14?
7, 2.
But the difference is 5. That's right, that's 7, 2. But because I need negative 5, then the larger number will be on the negative side. Okay, now I think the first key that you need to keep in mind is that if the constant term is negative, then the sign here must be different for sure, Okay, then from there you see, oh, what times what is 14, but the difference is negative 5. It's 5. It's 7 and 2 now, but because I need negative 5, then the larger number I put on the negative side. Okay, now what happens if we have positive ones on the last term? Let's say x squared minus 6x plus 8. Then it must be, if it is factorable, it must be parentheses and parentheses, x and x. Now, because the sign here is positive, then these two signs here must be the same, either both positive or both negative. Now, to decide, then I look at this guy. They must be the same, and because this guy here is negative, then it must be negative and negative. Okay. Now then, we go on. What times what equals to 8, but the sum, because we need the sum here, but the sum is 6. That is 2 and 4.
Two, 4. Oh, okay.
Okay, so if you see the way I do it, I do the sign first, and then I'll deal with the numbers. Now, there are actually many methods of factoring trinomial, though. There are, I know some people like to do that floor plan method. They start with this. So they say x and x, and then this is, for example, this is negative 2, and then this is negative 4, like that. Okay, if you feel comfortable with that method, go ahead, stay with it. Okay, just make sure you get the right answer, the right factoring. We don't have too much time to repair your factoring, so you rely on what you learned before. Okay, now, so, but Thomas, what happened if I forget my factoring? Then watch the lecture video from my intermediate algebra class, or even my beginning algebra class. Now, I show you the lecture videos resource from my videos yesterday, from my lecture yesterday. Okay, now that's for trinomial. I think trinomial with leading coefficient 1 is still on the easy side. The one that is on the harder side is when the trinomial has leading coefficient not 1. Now from here, I separated into two cases. Case 1 is when the leading coefficient is a prime number. Let's say, for example, we want to factor, let's say, for example, we want to factor 2x squared minus 5x minus 2. Now, my way of doing is the following. I'm sorry, plus 2, not 9. My way of doing is the following. I do parentheses first, right? And then the reason I separate the case of leading coefficient is prime and if the leading coefficient is composite is the following. Even though the leading coefficient is not 1, but because it is prime, it has only one possible pair, that is 2x and x. If it is factorable, it must be this way. Okay, and then second thing I see is this sign here. Because it's plus, it must be the same sign. Therefore, I will be able to see that same signs are, in this case, both negative. And then how about the numbers? Then I do trial and error. What makes it 2? What makes it 2? Either 1 here, 2 here, or 2 here, 1 here. Then you try one by one. Okay, but in this case, I can cancel this right away. This won't be the answer. This won't be the answer. I can cancel that right away. Why, Thomas, you know that that one is wrong? Because of the following. If this were the answer, notice that you have common factor 2 here. Right? This has common factor. Which is not the case in your original problem. In your original problem, you don't have common factor. That's why without computing, I can tell right away this is the wrong answer. Okay, but of course, it doesn't mean this must be the right answer. I still need to check that. 2x minus 1 times x minus 2. Okay, so 2x squared for the first term plus 2 for the last term. That one is guaranteed from the way we set it up. Okay, the middle term, we need to make sure that's negative 5x. This is minus 4x, and this is minus x. That's how we get that negative 5x. Okay. So if I redo this problem, redo this problem, get 2x squared minus 5x plus 2, it's parentheses, 2x and x, the sign both negative in this case, either 1 or 2 or 2 and 1. When I try this one, it works, that's it, boom. Now, let's do a more complicated problem. Example 2 here, we want to factor, let's say 3x squared minus 4 here minus maybe plus 4x. Now then, the leading coefficient is prime, so there's only one way to make it happen. It must be 3x and x. That's the only way. Now, because the sign here is negative, then we are guaranteed the sign of these two places has to be different signs. Let's put plus minus for now. It may be negative positive later on, but let me put plus minus for now. Now then, how about that 4? How to make that 4? It's either 1 times 4, 4 times 1, 2 times 2. Okay, when I try 1 here and 4 here, what do I get? For the middle term, I will get negative 12 plus 1 that will give me negative 11x in the middle. Nope, that's not what I want. That's not what I want. So I cancel this. Not this one. How about if I try 4 and 1? That will give me negative 3 plus 4. Negative 3 plus 4 will give me 1x. No, that's not what I want. That's not what I want. So I cancel that again. Four, 1 doesn't work. What happens if I try 2 and 2? When I try 2 and 2, I get negative 6 plus 2. Negative 6 plus 2 is negative 4x. But I need positive 4x. I need positive 4x. So what I will do then, if I need to change the negative 4x becomes positive 4x there, change the sign here. So make it positive here, and then make it negative here. Okay, now let me redo this problem. This time I show you how I will do it myself if I have this question. So 3x squared plus 4x minus 4. I will put 3x and x first, and temporarily I put plus minus. Then on my scratch work, you don't need to show me in this on your test. Actually, just factor it. Okay. On my scratch work, I do this 3x plus x minus 1, 4. I know it's either 1, 4, 4, 1, 2, 2. Negative 12 plus 1, negative 11. No, that's not what I want. Erase. Okay, so 1, 4 doesn't work. Now try 4, 1. That's negative 3 plus 4. That's positive x. No, that's not what I want. Erase. 1, 4 earlier, I already erased, right? And then try 2, 2. I get negative 6 plus 2. That's negative 4. Oh, but I need positive 4. Then I change the sign. Change the sign here, becomes minus. Change the sign here, becomes plus. Okay, so I now go back to my work, my formal work. I change the sign here. So 3x minus 2, x plus 2. Now from here, I would like you to realize one other thing. I call this variation. Call this example 2 with variation. Suppose I have this question, factor 3x squared plus 4xy minus 4y squared. When you see this kind of question in which the first term have x squared, the second term only x, and the last term constant, and for the y's you don't have y, you have only y, and then you have y squared. So the x actually decreasing in powers, while the y, the x is decreasing in the exponent. The x is decreasing while the y is increasing in exponent. So if you see this pattern, then you can do the one I write in black first. Okay, so basically you will get 3x squared plus 4x minus 4. That becomes 3x minus 2 and x plus 2. That's what we did earlier, right? And then to accommodate the y, I insert y here. Okay. Now, in my Algebra 1 class, I call this a skeleton case. Because when the author, the person who write this question, when the author wrote this question, he actually had this in mind. And the y is basically the variation. If you call this green color, I mean this yellow color here is the skeleton, and then the y will be the flesh. Okay, the flesh. It's kind of like put some flavor into that blend meal. Okay, that's for this example too, in which I put some variation. Okay, let's do one example from our textbook. This is question number 14. Question number 14, factor 7x squared plus 10x minus 8. Okay, let me give you 1 minute for this. So this will be 7x and x. Let me put for now plus minus 1, 8, 8, 1, 2, 4, 4, 2. 4, 2 will do. 4, 2 will do. This will give me negative 14 plus 4, that's negative 10. But I need positive 10. So what I do is I change the sign here and also change the sign here. Boom, that will make it. Then next, what happened if the coefficient is not prime? What happened if case 2, we're still in trinomial where the leading coefficient is not 1, but the leading coefficient also not prime. Suppose for example, the one we have in our textbook, example, question number 13, 8x squared minus 17x minus 21. Now again, if you have other method to do this type of factoring and you think it's faster, go for it. Okay, but for each type of factoring, including this level 4, the trinomial, when the leading coefficient is not prime, I do expect you to be able to do it in less than 40 seconds. Let's say around 40 seconds for this type. Okay, anything before that, less than 30 seconds. Okay, we don't have too much time. I cannot give you 5 minutes for this one problem. You are in Precalculus. Okay, you should be able to do some mental math quite fast. Okay, now the thing with the situation when the leading coefficient is not prime, then we have more than one possibility for this 8x squared. Okay, that 8 is not prime. So it's either 8x and x or 4x with 2x, but no other way, right? Basically, once the leading coefficient is not prime, then there is more than one pair to make that 8x squared. So I will write both of them first for now. Okay. Now then, I look at the sign here. Oh, it's negative. So let me put plus minus temporarily. It must be different, right? Plus minus here, and then plus minus here. Then I need to catch that 21. So it's 1 times 21, 21 times 1, 3, 7, 7, 3. Well, I do likewise here. 1, 21, 21, 1, 3, 7, 7, 3. So there are actually 8 options. Okay. I write all the possibilities first. In other words, it feels like create your own multiple choice. You create your own multiple choice, and there are 9 possible answers. 8 of them here, and the other one is non-factorable if none of these works. Okay, but make sure you write all the possible outcomes first before you start computing. Okay, now then after some practice, you will see that I can do it quite fast because I've practiced a lot in the past. This will do. This pair here. This will do. Okay, in fact, that will give me exactly negative 17x. I don't need to change the sign anymore. Okay, there are a lot more secrets, quote unquote secrets, in doing factoring for leading coefficient not 1 and not prime. But instead of going too far into details on right now, I'd rather just leave it there. Okay, now that's the 4th method. The 5th method is special factoring. Now the first one is on difference of squares. We have seen that before. Difference of squares has the pattern of a squared minus b squared equals to a plus b, a minus b. It has to be minus though, okay? With some extra notes, sum of squares is not factorable without using complex number. So let me just say for now, sum of squares is not factorable. Okay, now we have seen that before and we'll see that again. The second case from special factors that you have to keep in mind is the perfect square case. If it satisfies this pattern, a squared plus minus 2ab plus b squared. If it satisfies this pattern, then it is a plus or minus b in square. For example, number 18 in our textbook. Number 18 in our textbook, we have 9x squared plus 24x plus 16. Now, of course, you can treat this as a trinomial with leading coefficient composite number. The leading coefficient is trinomial, and leading coefficient is not 1, it's not prime. Yeah, you can treat it that way. Okay, but what I want to emphasize is this. If you see a trinomial where the leading term, the first term, and the last term are both square expression, you see this 9x squared comes from 3x being squared, right? And this 16 comes from 4 squared. Then you should suspect that it may be, every time you see this situation, suspect that it may be perfect square, so you check this pattern first. Okay, what pattern comes? You take the base from each one of them, and then take the product, 3x times 4. Take the product of the base and double down. Double it. Does it match? If it matches, then it is a perfect square. In this case, 2 times 3 times 4 gives me 24, and then with the x, so it matches, right? Now, once it matched, then it must be a perfect square case where the first term is 3x plus the second term is 4 being squared. Okay, so let's see another example. Another example, this time this is an example. Suppose I have this. Let's say factor 4x to the 4th minus 28x squared y cubed plus 49 y to the 6th. Now you may say, what the heck, Thomas? And let's see, you see that the first term here is a squared expression whose base is 2x squared. Right? And then the last term here is also a squared expression whose base is 7y cubed. Now take the product. Take the product and multiply by 2. Okay, take the product, multiply by 2. So 2 times 2x squared times 7y cubed. 2x squared, 7y cubed. Now don't forget to double it. Okay, don't forget to double it. Does it match? 2 times 2 times 7, that's 28. We have x squared, we have y cubed. Yes, it matches. So this must be a perfect square case. 2x squared minus 7y cubed being squared. You definitely do not want to do this problem using level 4 method that we did earlier, the trinomial. You don't want to see this from trinomial point of view, even though it is trinomial. It is trinomial. Okay, it is trinomial. So you can do it that way, but it takes a lot longer time simply because you have more variables with higher exponents and the numbers get a bit larger, right? So for perfect square, we follow that pattern. Now, the last pattern, the last special factoring is sum and difference of cubes. Now, this one, I know a lot of incoming students from Algebra 1 or beginning algebra, students from Algebra 2 or intermediate algebra, don't memorize this yet. And if you are one of them, well, don't worry. I give you a chance to catch up, okay? But you're supposed to memorize this factoring already at this point. But if you don't worry. I need you to memorize that from today, okay? X cubed plus y cubed has the pattern of x plus y times x squared minus xy plus y squared. Now first, take a look on this pattern. If that's a summation here, sum of cubes, then the first factor is a sum. The second factor is opposite and always positive. Okay, so the one here always the same. The one here always the opposite. And the last term always positive. So somebody give a mnemonic so. Okay, why? Because if later on you have x cubed, sorry, if you have x cubed minus y cubed, then the signs will be minus here, plus here, always positive. Okay, that's the pattern. Now then, how about the first factor? The first factor will be the base and then the base. The second factor, base squared, the product of both bases, and then the base squared. Okay, so you see the pattern for the sign, it's same, always opposite. I mean, same, opposite, always positive. Okay, now it does take some time, I believe, for you to memorize this, but for this semester, you have to memorize it starting from the hour we finish the lecture today. Okay, so tomorrow, I assume you memorize this already. We don't have that much time though. Okay, you're supposed to have memorized this since Algebra 1. If you don't, then in Algebra 2, you should have memorized this. Maybe because you have not done math for quite a while, then you forget it. Now you have to memorize it. Okay, once you go to calculus, you will see there are so many things you have to not only memorize in your mind, but also memorize by your heart. You need to feel it already. Okay, and again, please be aware that x cubed minus y cubed is not the same to x minus y cubed. No. X cubed plus y cubed is not the same to x plus y cubed. Actually, it applies also to squares. X squared plus y squared is not the same to x plus y squared. Okay, x squared minus y squared is not the same to x minus y squared. So Thomas, where did I see something similar to that? You saw it here, x squared y squared is the same to xy being squared. For multiplication, that's true. But for addition and subtraction, that's not true. Okay, so please be aware with this though. Please be aware with this. Okay, by this time, you should have memorized it. Now, then let's do some example here. Suppose I have, let's do the simple one first. Let's say I have x cubed minus 8. I would like to rewrite this into difference of cube first. And then use the pattern I have above. For now, you can cheat, right? This is difference of cube. So the first factor will be the base, same base. And then the second factor will be, the sign will be opposite, always positive. And then the first term of the second factor is the first base square. The last term of the second factor is the second base square. Now the middle term will be the product of those bases. So then I get x minus 2, x squared plus 2x plus 4. Some little notes. Oops, little notes. The second, I think I should say the trinomial factor. The trinomial factor of the trinomial of the sum or difference of squares of cubes is rarely factorable further. And even if it is doable, it must be so hard to do. Basically, it's not at your level anymore. Okay? So you see that this is trinomial, right? Then you may wonder, can I factor it further? It's very, very rare. It's very, very rare that you can factorize that even further. And if it is factorable further, it must be so hard to do. Okay, it must be so hard to do. Okay, now let's do slightly harder one before I give you a break with one example. Suppose I have, this is from the book, number 22. Factor x to the 6 minus 27y cubed. Now, I will rewrite this first. I want to see it as difference of cubes. So this is x squared being cubed minus 3y being cubed. Write it that way first so that you know what is your a, what is your b, right? Okay, what is your a, what is your b? What do you mean by a or b times? I mean the following. This is my first term. This is my second term. When I factor it later on, I will have two factors, the binomial factor and the trinomial factor. The sign will be the same, opposite, always positive. And then how about the factors, the terms? This will be the same base, something being squared, something here, something here, something here, something squared here. Okay, I use color so that you can see the pattern. So yellow cube minus blue cube is yellow minus blue, yellow square, yellow minus blue, yellow square plus yellow blue plus blue square. Okay, now then I replace the yellow and the blue by the corresponding expression. Then from there, I simplify further to make it look better. So I get, oops, this is x to the 4th plus 3x squared y plus 9 squared. Okay, so what I did first here, I rewrite it into difference of cube first so that I know the basis. And then I follow the pattern of the factoring and then simplify further. Okay, now that's what I did there. Let me ask you to do one problem from our textbook. I hope that's not too hard to do. Number 24. I think this one is not too hard to do. Number 24. That should take you only 1 minute if you memorize it, or 40 seconds to be more precise. But this time I give you, let's say, 2 minutes. Together with your break, we come back at 1:17. Okay, let's continue. We can rewrite this as x cubed plus 4 cubed. So that will be same sign, opposite sign, always positive. The bases are x and 4. This is base squared, 4 squared. Let me just write it as 16 right away. It's quite simple anyway. So this 16, which is 4 squared, and the middle term will be base times base. Okay. Now let's go on in simplifying rational expression. So the third part of this section here is multiplying. I don't think I can finish this though in 40 minutes, but let's do most of it. Okay, so part C, simplifying rational expression. A lot of factoring here. So let's see, for example, I do the easy one first. Okay, for example, number 32. If we have 12 simplified, 12 plus r minus r squared over r cubed plus 3r squared. So you see on the top, I need to do the trinomial, factor the trinomial. And at the bottom, I have common factor r squared. Let me do the bottom first. The denominator, I have common factor r squared, r plus 3. Now, the numerator, there are two ways to factor it. Either you factor it directly. If you can do it, go ahead if you want to factor it directly. Or you factor the negative and rearrange first. Okay, so for example, if you want to rearrange that first, negative r squared plus r plus 12, and then factor the negative. And then you factor further, r plus 3, r minus 4. Okay. Okay, so you say this is negative r plus 3, r minus 4. And we have something to cancel there. So we end up with negative of r minus 4 over r squared. Now we can absorb the negative. We can absorb the negative by reversing the order of subtraction. So we can have 4 minus r over r squared. Now you remember this, that a minus b is the opposite of b minus a. I actually use that property there. Okay, that's what I did there. Now I said earlier that you may be able to factor it directly. So the way I see is like, oh, you know what? It's r squared here, it must be r and r. It's minus here, should be plus minus. Okay, what times what is 12, but the difference is 1. So it will be 4 and 3. At the bottom, I have r squared, r plus 3. And notice that these two cancels, and I get 4 minus r over r squared. Number 34. What happens if we divide rational, two rational expressions? 5a squared plus 12a plus 4 over a to the 4th minus 16 divided by 25a squared plus 20a plus 4 over a squared minus 2a. In number 33, you see a multiplication problem. Now, what happens if we have division problem? The first step is multiply by the reciprocal first. So I will change this division becomes multiplication. Okay, and then I do the reciprocal here. Okay, so I get 5a squared plus 12a plus 4 over a to the 4 minus 16 multiply by a squared minus 2a over 25a squared plus 20a plus 4. Then the next step will be factor each one of them. Okay, factor each one of them. Let me give you some time to factor each one of them. And when you factor each expression here, do it aside. Don't do it here. Don't do it right below it. No, no, no. Your scratch work should be done either on scratch paper on a side, not right below it. Okay, not right below it. That's to make your scratch work and your main work still neat enough. Okay, so let me ask you to factor this. I think that's trinomial leading coefficient of prime. This one is a simple common factor problem. And the one here, I believe this has something to do with perfect square. Now, the bottom left, however, is difference of squares, but you need to do it twice, I believe. Yeah, you need to do it twice. Now, let me give you, let's say, 3 minutes for this. Okay, let's see, this will be 5a and a plus 2 plus 2. This is a squared plus 4. A squared, I'm sorry, a plus 2. A minus 2. This guy here will be a times a minus 2. And this will be 5a plus 2 squared. Right? Canceling, notice that I can cancel 5a plus 2 with one of these. So I still have 5a plus 2 on the denominator. And then I can cancel this guy with this guy. Cancel this guy with this guy. So in the end, I have on the numerator a only over the denominator a squared plus 4 times 5a plus 2. Okay, so from this one example, I actually teach you two things at once: how to multiply and divide rational expression. To divide rational expression, you convert that to multiplication by the reciprocal first. And then how to proceed from there, you factor, cancel whenever possible. Okay, that's for number 34. Now, what happens if we add and subtract? Now, let's do a little review. From pre-algebra. Suppose I need to add 3 over 8 by, let's say, 5 over 6. I have two fractions that I need to add, so I need to first find the LCD, least common denominator. I need to find the least common denominator. Okay, now what is the least common denominator of 8 and 6? you know that should be 24, right? Okay, now we get that 24 because we are pretty good with numbers. But what happens if we have expression? We need to borrow some more fundamental technique we did when we were in pre-algebra. This 8 can be written as 2 cubed, and 6 can be written as 2 times 3. Now, the LCD, or in this case, least common multiple of 8 and 6, is therefore, for the same base, you pick the higher exponent. For any same base, you pick the higher exponent. Okay? So for that one, nothing and 3, we will use 3. This is 8 times 3, that's how we get that 24. Now, once I get the LCD, which is 24, then I do some adjustment on the numerator. For the first fraction, I multiply the denominator by 3. So on the top, I need to multiply by 3 as well. That becomes 9. The one here multiplied by 4. So on the numerator, I multiply by the same number 4, it gives me 12. Okay, so we basically find the LCD first. Find the LCD first, and then adjust the numerator. Then we can add, or in other case, we will subtract. Okay, so this will be 29 over 24. Now, we will use that idea for, let's say, for example, number 38 first, the easy one first, number 38. Oops. Number 38, 5 over x minus 2x minus 1 over x squared plus x plus 7 over x cubed. No, I'm sorry. I think I looked at the wrong one. Did I look at the right one? Oh, yeah, that's right. Now, then you see we have the denominator x, x squared, x cubed. They have the same basis, right? All base 3. I mean base x. And if they have the same base, choose the highest exponent as your LCD. Okay, so here the LCD will be x cubed. The base here already the same, right? So I don't need to do any adjustment for that one. This will be x plus 7. The thing is, for this guy here, I multiply by x squared. So the numerator will be multiplied by x squared. And for the second denominator here, I multiply by x. Therefore, on the top, I multiply by x. That will be x times 2x minus 1. So I now have LCD with all the numerators already adjusted. Let me make it nicer first. 5x squared over x cubed minus 2x squared minus x over x cubed plus x plus 7 over x cubed. Now put them together. 5x squared minus 2x squared minus x plus x plus 7. Now I need to use parentheses because you see that later on I need to distribute this negative to both of these terms here. Okay. I hope you are aware with that. I'll go on further. I distribute 5x squared minus 2x squared plus x plus 7 over x cubed. We now have 3x squared plus 2x plus 7 over x cubed. Okay. Now, the nice thing about this question is we have only one base x, so we can easily choose the highest exponent. Now, what happens if we have different bases? Then for each base, you choose the higher exponent. Let's say, for example, we do number 42. Oh, by the way, for this part here on the top, you should try to factor it. Okay, you should try to factor it. I know it's not factorable. I can tell you right now that it's not factorable. But if it is factorable, you should factor it. Now, then let's answer one question that we will we need to discuss sometime in the future anyway. How do we know that this trinomial is not factorable? And the answer is I borrow something from our quadratic topics that we're supposed to cover in chapter 2 or maybe chapter 3, is that the discriminant has to be a square number. The discriminant is b squared minus 4ac. Is a square number then it is factorable. Okay, so if it is not a square number, it's not factorable. Let's see. B squared minus 4ac. Right, that's the discriminant. That's 4 minus 84. That's a negative number, of course, therefore it is not a square number. Of course, in my test or quiz, you don't need to give this long explanation, right? If it is factorable, then you factor it. If it is not factorable, you just leave it like that. Okay, but behind that decision, should I factor it further or not, then you do this at least at the back of your mind or on your scratch paper. Okay, check if the discriminant is a square number or not. If it is not a square number, like in this case, especially because it's negative, then it's not factorable. Okay, let's do the following question. We do on the right hand side, number 42. Number 42, the question is 12x over 2x plus 1 minus 3 over 2x squared plus x plus 5x. Now the purpose of doing factoring, so that you see the denominator here, factor it first. That's x times 2x plus 1. Then from there you see, can you tell what's the LCD? You have 2x plus 1 as the factor. The highest exponent is just 1. right? So the LCD will consist of 2x plus 1. And we also have x. And they happen to be the same exponent 1. So in my LCD, I have that x also as a component for the LCD. So you see this x times 2x plus 1 is a multiple of 2x plus 1. And this same LCD here, also a multiple of x, right? Okay, so using that LCD, let me copy paste that here. X plus 2, x times 2x plus 1, x times 2x plus 1, x times 2x plus 1. Now adjustment. For the first term, I already have this. I was missing x. So the first term will be 12x squared, right? For the second rational expression, the denominator actually the same, so no adjustment necessary. For the last fraction, I already have x on the denominator, so I still need to multiply by 2x plus 1. Now, once they have LCD, then we can put them together. Let me just put them together now. And of course, in between, I will distribute this. Okay? So I will get 12x squared minus 3 plus 5 times 2x plus 1. I will distribute that later then. X times 2x plus 1. Distribute, oops, sorry, it's too far. Distribute, I will get 12x squared minus 3 plus 10x plus 5 over x times 2x plus 1. So I get 12x squared plus 10x plus 2 over x times 2x plus 1. Now, we should factor the top. At least you know that we have common factor 2 up there. 2 times 6x squared plus 5x plus 1. Now, do you think that thing is factorable? And you should try, at least look at the discriminant, right? Look at the discriminant, 5 squared minus 4 times a times b. That's 5 squared minus 24. That's 25 minus 24, that's 1. And 1, of course, is a square number. It means it is factorable. You better factor it if so. Okay, so when I try to factor it on the top, I know the sign should be plus and plus. It must be 1 and 1 here. So this is 3x, this is 2x. Okay, do it your way though, when you factor it. Okay, at least then finally, my final answer is 2 times 3x plus 1 over x. Now, once you're done copying that, let's do one last problem before I let myself go. You can stay if you want to, but I will go after 2 o'clock. Number 48. 4x plus 12 over x squared plus 6x plus 9 plus 5x over x squared minus 9 plus 7 over x minus 3. Now, I would like you to do this. I can tell you the factor part. Let me do the factoring, a bit factoring for you. So you will have x plus 3 squared here. You will get x plus 3, x minus 3 here. Okay, and actually, if you think about it, you can factor the 4 here. It becomes 4 times x plus 3. Okay, now use these informations. Try to simplify this, basically add them and simplify as much as possible. Okay, let me give you 3 or 4 minutes for that. Finish it up. So I get 4 times x plus 3 over x plus 3 squared. Now they happen to be cancelable. If you want to do so, go ahead. Let me rewrite it first. So you see that I can cancel this, right? One of these. So now my LCD becomes x plus 3 to the power of 1 and x minus 3 to the power of 1. X plus 3 to the power of 1, that's the highest. X minus 3 to the power of 1 is the highest. And this will then be x plus 3, x minus 3, x plus 3, x minus 3, x plus 3, x minus 3. And then on the top here, I already have 4. I was missing x minus 3. Here, nothing changed. They already have the same denominator. The last term here, I have 7. I need x plus 3. Now, let's go on. This will then be, let me put them together. I think I can distribute them at the same time, huh? It's all adding anyway, so there's no danger of distributing negative. 4x minus 12 plus 5x plus 7x plus 21. That will give me 16x plus 9 over x plus 3, x minus 3. I will leave them in factored form. Okay, now your suggested homework from this 1.3a, you don't need to turn in suggested homework though. Okay, the first part here will be from number 1 to number 47. Just do the odd ones. Now, I understand for some of you, this is quite boring. Thomas, this is too easy. Trust me, if it is boring for you, imagine me. I've been teaching Precalculus for too long, not to say that I took calculus long time ago. So for me to slow down and teach you this way, it does take me a lot of patience. Okay, then you too. The reason I go over this because I do not want any algebraic issue, any algebraic problem becomes an issue later on once we really step into the real material for Precalculus. Okay, I need you to be strong at the time. So if you ask me question, Thomas, I don't remember how to add fraction. What I will do is I just ignore you. Okay, it's not my job to teach you how to add fraction. It's somebody else's job. It's your previous teacher's job. But Thomas, it was a long time ago. That's your issue. Okay, there's only so much I can take. There's only so much I'm willing to help. Okay, if you want to come to my, ask me about, Thomas, can I have office hour with you to ask you some questions? I will welcome that, but of course I will not go over material that I already went over during our class time. Okay, if you want to do further review with me, then ask me for office hour. Okay, yeah, that's the suggested homework for today. Tomorrow we will continue with 1.3. That's still a pretty long part, not that long, but long enough. And we will spend most of our time with 1.4. 1.4 is a long section. I know it seems like I'm getting too much into details, but I want to make sure that when it comes to solving equation, we have no issue at all in future. Okay, so if you already have the book, please read further in 1.3 and 1.4. Okay, so tomorrow I will do 1.3, 1.4, and then on Thursday I will do 1.6, 1.6, and then if possible 2.1. And then on Friday, I do almost finish chapter 2. Okay, now your test 1 will include chapter 1 up to 2.6. Your test 1 will be chapter 1 up to 2.6. Okay, now see you then tomorrow.
Thank you.
You're very welcome.
Have a good day.
You too.